Good day everyone, my name is Tracy Pell and today I will be discussing to you about blood pathway and its components. So without further ado, let us begin. The blood vessels of the body is functionally divided into pulmonary and systemic circuit. Pulmonary circulation moves blood between your heart and the lungs. It transports the oxygenated blood to the lungs to absorb oxygen and release carbon dioxide. Oxygen-poor blood coming from all over your body enters your right atrium through the two large veins. So from the upper portion, we have the superior vena cava, and from the lower portion, we have inferior vena cava. Next, your tricuspid valve opens to let the blood travel from your right atrium to your right ventricle. When your right ventricle is full, it squeezes, which closes your tricuspid valves, and your pulmonary valves open. Then, your oxygen-poor blood will flow through your pulmonary artery going to your lungs. Inside the lungs, the oxygenated blood coming from the pulmonary artery will enter your capillaries. The capillaries encloses your alveoli, where the gas exchange happens. Now it is time for the alveolus to do its work and produce oxygen-rich blood in the form of your red blood cells. And then your red blood cell will be traveling to the pulmonary vein. The next steps will already be under your systemic circulation, which is the movement of blood from the heart through the body to provide oxygen and nutrients to the tissues of the body while bringing deoxygenated blood back to the heart. So your oxygen-rich blood will travel from your lungs to your left atrium through the large veins called your pulmonary veins. Your mitral valve then opens to send blood from your left atrium to your left ventricle. When your left ventricle is already full, it squeezes, which closes your mitral valve, and it opens the aortic valve. Your heart sends blood through your aortic valve to your aorta, where it flows to the rest of the body. Now, let us move on to the blood components. Blood is a combination of plasma and cells that circulate throughout the body. It supplies essential substances such as sugar, oxygen, and hormones to cells and organs to remove waste from the cells. Hematologists work to identify and prevent blood and bone marrow diseases. They also study and treat the immune system, blood clotting, and blood vessels. Here are the different blood components. We have plasma, RBC, WBC, and platelets. Whereas, your whole blood is a mixture of about 55% plasma and 45% blood cells. Plasma is the liquid part of the blood. It contains proteins and antibodies that are crucial for clotting and immunity. Plasma is composed of water, which is 92%. The remaining 8% includes glucose, hormones, proteins, mineral salts, fats, and vitamins. Plasma is in high demand as it helps to treat cancer and other health issues. Plasma donation or apheresis involves drawing blood, extracting plasma, and returning what is left of the blood to the person, although single needle remains in the arm throughout the process. It is relatively a safe procedure, but there are minor side effects that includes fainting or dizziness, bleeding, bruising, or inflammation around the donation site. Rarely, an embolism can also occur. In May 2020, the Food and Drug Administration or FDA conducted a blood plasma donation wherein they asked people who had recovered from COVID-19 to donate plasma. The experts believe that the plasma may contain antibodies for SARS-CoV-2, the virus behind the disease, and that receiving plasma with these antibodies could help a person fight off the infection. Hence, people with AB blood have a universal type of plasma, which means that a person with a blood type with this blood type can receive this plasma safely. Let us now move on to the RBC. Red blood cells have a slightly indented, flattened disc shape. They transport oxygen to and from the lungs. Hemoglobin is a protein that contains iron and carries oxygen to its destination. The lifespan of your RBC is 4 months, and the body replaces them regularly. The human body produces about 2 million blood cells for every second, and the expected number of red blood cells in a single drop per microliter of blood is 4.5 to 6.2 million in males and 4.0 to 5.2 million in females. Meanwhile, hematocrit is the percentage of red blood cells in a person's blood. A typical hematocrit range in healthy adults is 37 to 52%. This varies depending on a person's sex and age. If a person feels tired, dizzy, or short of breath, a doctor may want to test their hematocrit levels to see if those levels fall into the normal range or not. Low red blood cells indicate conditions such as anemia, and high red blood cells could signal polycythemia, which increases a person's chance of developing a blood clot. Next is the WBC, your white blood cells or your leukocytes. They make up less than 1% of blood content, forming vital defenses against disease and infection. The bone marrow continuously produces them and are stored within blood and lymphatic systems until they are necessary for fighting an infection or disease in the body. The number of white blood cells in a microliter of blood ranges from 3,700 to 10,500. Higher or lower levels of these white blood cells can indicate a disease. There are two types wherein your leukocytes can be classified. We have granulocytes and agranulocytes. So to be classified, here are the criteria as you can see on the screen. Under the granulocytes, we have first the neutrophils. These are powerful white blood cells that destroy bacteria and fungi. Eosinophils are responsible for destroying parasites and cancer cells, and they are part of an allergic response. Last under granulocytes are basophils. These alert the body to infections by secreting chemicals into the bloodstream, mostly to combat allergies. Next are the agranulocytes. First under this is the lymphocytes. They are vital for producing antibodies that help the body defend itself against bacteria, viruses, and other threats. Next is the monocytes. They are responsible for attacking and breaking down germs or bacteria that enters the body. When necessary, monocytes travel to other organs such as the spleen, the liver, lungs, and bone marrow, where they transform into a cell called macrophage. Your macrophage is responsible for many functions, including removing dead or damaged tissue, destroying cancer cells, and regulating the immune response. So the high white blood cell count may indicate that the immune system is working to destroy an infection. On the other hand, a low white blood cell count can signal that an injury or condition is destroying your cells faster than the body is making them, or that the body is producing too few of them. Next are the platelets. Platelets interact with clotting proteins to prevent or stop bleeding. There should be between 150,000 and 400,000 platelets per microliter of blood. A person's platelet levels can change depending on the age, certain medical condition that can affect them. A platelet count that is too low or too high can lead to health complications. If it is too low, this is called thrombocytopenia, while if the platelet is high, it is called thrombocytosis. Tests measure average platelet levels per microliter of blood. So now let us move on to the blood diseases. For this discussion, we have two. First is the sickle cell disease and the second is your blood cancers. Sickle cell disease is an inherited trait that causes your red blood cells to take on a crescent shape. It affects over 100,000 people in the United States, wherein mostly are Black Americans. It can severely impact how blood functions and can be life-threatening. Unfortunately, blood and bone marrow transplant is currently the only cure for this disease, but symptoms may be reduced by some oral drugs such as voxelotor, hydroxyurea, and crizanlizumab, which is an injection. Next, moving forward, we have the blood cancers. Cancers such as leukemia, myeloma, and lymphoma occur when blood cells start to divide uncontrollably without dying off at the end of their life cycle. So the treatments that is used for blood cancer include chemotherapy, immunotherapy, radiotherapy, and stem cell transplant. Here are the references that are used in preparing this presentation. Thank you so much for listening and have a nice day.